OCR Maths and Stats differentiation techniques for C3 and C4, differentiating the parametric form for the equation of a curve. So as we see here, we have two equations, one for x, one for y. So x and y are variables, but they are both given in terms of a third variable here, which is t. So as t varies, both x and y vary. The gradient of the curve can be worked out by using this chain rule. So dy by dx, the change in y over the change in x, the gradient of the curve, is given by dy by dt, so you have to differentiate y with respect to t, times dt over dx, so you work out the derivative of this, so you get dx by dt, and you have to flip that over to get dt by dx. So we're using the chain rule. So in this example we have a curve which is defined by a set of parametric equations. So first of all, differentiate each one, so that's x in terms of t, so work out dx by dt. And this is y in terms of t, so work out dy by dt. Now we can link these two derivatives using the chain rule here. So dy by dx is equal to dy by dt, so 4t cubed, times dt by dx. Now this derivative is dx by dt. To get dt by dx, we need to flip over both sides, so we get 1 over 6t. And then simplifying, the 4 over 6 gives us 2/3, and t cubed divided by t will give us t squared. So to work out the gradient of the curve at any point, we need to know the value of the parameter t. So once you know the value of t for a particular point on a curve, you substitute that value into here, and you'll be working out the gradient of the curve, and hence the gradient of the tangent, and from there perhaps the gradient of a normal. You could work out stationary points and so on. In this example we have two parametric equations, but in terms of trig, the method is still the same to work out dy by dx, and hence the gradient of the curve at any point. So dx by d theta, so differentiating sine 2 theta gives 2 cos 2 theta, and then differentiating y with respect to theta, so dy by d theta is equal to minus sine theta, and then using the chain rule, so dy by dx here, dy by dx is equal to dy by, and we're using theta instead of t, so dy by d theta, which is minus sine theta, times, and this will be d theta by dx, so we have to flip this over, so 1 over 2 cos 2 theta. So to work out the gradient of any point on the curve, you need to know the value of the parameter theta that you're going to substitute into here. In this example we have two parametric equations using the exponential form, and before we start, this here is not e to the power of 2t minus 1. That minus 1 is separate from the e to the power of 2t term. So differentiating x with respect to t, so dx by dt is equal to 4 e to the power of 4t, and doing the same with y, so dy by dt is equal to 2 e to the power of 2t, and then using the chain rule to link these together, so dy by dt is equal to dy by dx is equal to dy by dt 2 e to the power of 2t times dt by dx, so we have to flip this one over, so 1 over 4 e to the power of 4t, and the 2 over 4 is just the half, so we've got e to the power of 2t over 2 e to the power of 4t. Now the bases here are the same, so we can subtract the indices, so that will give us a half e to the power of minus 2t.